Next, we'll be going over some electricity and magnetism. This is, we just finished like pretty much, we just covered lots of the fundamental concepts in mechanics. So now we will be moving on to electricity and magnetism. So the main thing we see in like science bowl, electricity and magnetism is current electricity. So electricity that flows in a current, like in a circuit, for example. And in circuits, there are many different quantities you can measure. Uh, okay, so I see some questions. Let's see. I see, so just a reminder, like G is the acceleration due to gravity. When something, okay, so when you drop a ball or you drop something off of some tower or something, if something is falling only due to gravity, it will accelerate with this exact same acceleration, which is equal to G, which is equal to around 9.8 or around 10 meters per second squared. I also see, all right, so does air resistance do anything in physics? Air resistance is it has very great effects in physics, but usually we choose to ignore them. There are like models, there are like equations to model air resistance, but they're very complicated and usually we don't want to deal with air resistance. And in lots of problems, we just assume that there's no air resistance. All right. So here in conservation of momentum, okay, so how do you know these balls will stick together? We know these balls will stick together because that's what the problem says. Sorry if it didn't really make that clear, but the problem that like I made up in this example is that these two objects will stick together. If they stick together, that makes the problem a lot easier because then they stick together, we can just treat them as like one object. But they don't always have to stick together in like collisions. But conservation of momentum in collisions will always hold. All right, so now we can move on to electricity and magnetism. Okay, so as I mentioned, electricity and magnetism in Science Bowl mostly covers like current electricity in like wires in a circuit. So in a circuit, there are many different quantities you can measure, like current, voltage, and resistance. So here I have this animated picture over here. And current is just the amount of flow of electricity in a circuit. So it's just how much electricity can pass through in the circuit, like per some amount of time. It's like how much electricity flows. And then there's voltage, which is known as the electric potential. It is similar to potential energy, and it's kind of like similar to electric potential energy. And then there is resistance, which is how easy is it, or rather, how difficult is it for electricity to pass through the wire, or doesn't have to be a wire, through anything in the circuit. So it's how much the wire opposes current. Yes, it is the resistance to the flow of electricity. And in current electricity, there are also two important formulas for you to know, and one is called Ohm's law. Ohm's law relates these first three quantities that I talked about, current, voltage, and resistance. And it states that current, which is like denoted with an I, is equal to voltage, which is denoted with a V, divided by R, which stands for resistance. So current equals voltage divided by resistance. And this will just relate the current, voltage, and resistance in a simple circuit. So that is Ohm's law. The second equation to know would be electrical power. So it's how much power a circuit supplies, or an element of a circuit supplies. And electrical power is equal to IV, or the current, multiplied by the voltage. IV, this current multiplied by the voltage, can also be written as the current squared multiplied by the resistance, or the voltage squared divided by the resistance. If you manipulate this IV using Ohm's law. So these are all equivalent. But electrical power is equal to current times voltage. So over here we can see, a cross section kind of wires, and we can see that there's a positive side over here and there's a negative side to the right. And for the blue things at the bottom, those are negatively charged, and they'll typically, probably in a wire, be electrons, moving electrons, and they will try to flow towards the positive side because negative and positive attract. Now we have positive charges on the top, and this just shows that the positive charges in the wire that can move around will try to flow towards the negative side of the wire.